Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss questions on waves and Doppler effect from Cambridge AS Physics Paper 2. And this paper is from March 2021. Part A is simply asking us to state the principle of superposition. Principle of superposition simply tells us when two waves meet at a point, how we can find the resultant displacement of resultant wave. Let's try to understand this one a little bit in detail before we write our final answer for this question. You can see here in this figure I have already drawn three different waves. Let's say this wave is wave 1 and this is second wave, and the third one is resultant wave of these two wave. If you look at this point, you can see the displacement of black wave. So this is displacement of black wave. But at the same point, second wave, it also have displacement. Blue wave, this has also displacement. And this is the displacement of blue wave. But if we add these two displacements together, we can find the displacement of resultant wave. Simply, you need to add displacement of these two waves. Now, let's look at this point now. At this point, you can see blue wave, it has negative displacement. So this is displacement of blue wave. But the black wave, it has positive displacement. And this is displacement of black wave. But if we add these two together, one is positive, one is negative, we can find the resultant displacement of resultant wave. And this is resultant displacement of resultant wave. Now, if we look at this point, wave 1 and wave 2, they have zero displacement. So the resultant displacement of resultant wave is also zero. This is what you need to understand about principle of superposition. Now let's try to write down our final answer. So this is how you can state principle of superposition. Simply you can say when two waves meet at a point, the resultant displacement is equal to the sum of individual displacement of each wave. For part B, it is given to us that a transmitter produces microwaves and these microwaves are traveling in air. Meaning air is the medium, very important. And they're moving towards a metal plate. Experimental setup is shown in figure 4.1. We can see here we have microwave transmitter. We also have microwave detector, or simply we can say microwave receiver. Metal plate is also placed at the end. And it is also given to us that the wavelength of these waves is 0.040 meter and stationary waves is formed between transmitter and the plate. Question is simply asking us explain the function of the metal plate. I mean, why do we need metal plate in this case? First thing we need to understand is that stationary wave is a resultant wave of two waves. If there is only one wave, there will be no stationary wave. So it means we need two waves. Means we need one incident wave and one reflected wave. So when those two waves they will meet, they will form stationary wave. So the purpose of this metal plate is to reflect microwaves. So this is very simple how you can answer. If you look at this one, I have already drawn here. So this picture is very clear to see how stationary waves are formed between metal plate and microwave source, or you can say microwave transmitter. Now the function is simply, the function of this metal plate is to reflect microwaves. So this wave is reflected wave. This is reflected wave and this one is incident wave. This one is incident wave. Here is final answer. So this is how you can write down your final answer for this question. For the second part, we need to calculate the frequency of the microwaves, but our answer has to be in gigahertz. Frequency of wave simply is equal to the speed of the wave in the medium divided by wavelength of the wave. In this case, the wavelength of microwaves in air is given, that is equal to 0.040 meters. This is given to us. Now the question is that what is the speed of microwaves in air? We have discussed that all electromagnetic waves, they travel at speed of light in vacuum. So this is speed of electromagnetic waves in vacuum. But the speed of electromagnetic waves in vacuum is almost equal to speed of electromagnetic waves in air. So the speed of electromagnetic waves in air is also equal to 3 times 10 to 8 meters per second. Microwave is also an electromagnetic wave, so its speed is also equal to 3 times 10 to 8 meters per second in air. So simply we can write down here. So the speed of microwave in air is 3 times 10 to 8 meters per second. If we solve this one, our final answer will be 7.5 times 10 to 9. This is answer. But we need to write down our answer in gigahertz. So this is simply 7.5. So our final answer is 7.5 gigahertz. For third part, it is given to us that a microwave receiver is initially placed at position X where it detects an intensity minimum. The receiver is then slowly moved away from X directly towards the plate. Means first of all, detector is placed at this point and this is position X and it detects intensity minimum, means at this point there is node, and then this detector is moved to the right, detects another intensity minimum, or simply you can say node. Node is detected at this point, and question is asking us to find the shortest distance between these two nodes, and the distance between two nodes, it is equal to lambda by 2. So simply we can say distance is lambda by 2, and the value of lambda, that is equal to 0.040 meters. Simply we need to divide this by 2. So this is our final answer for this part. For the second part, we need to determine the number of intensity maxima. It simply means that we need to determine the number of antinodes when the detector is moved from position X to a new position that is 9.1 centimeter away from X. So it simply means that at this point our detector was placed at this position, means at position X. Then we move our detector to the right and the new position from this one is 9.1 centimeter away. We have already discussed that the distance between two nodes, that distance is equal to 0.020 meters, or simply we can say this distance is equal to 2 centimeters. So if we move detector from here to here, so this distance is 2 centimeters. Then if we move to next node, it will cover extra 2 centimeters. If we place at this point, so the distance from X will be equal to 6 centimeters. If we place here, distance between X and this new position is 8 centimeters. In question, we have to move this one by 9.1 centimeters. So it means we have to move up to this point, up to here. Otherwise, simply you can understand, if we move to this one, distance will be 10 centimeters, but we have to move by 9.1 centimeter. So distance between X and the new position here, distance is 9.1 centimeters. Now question is asking us determine the number of intensity maxima. So this is one intensity maxima, so this is 1. So here we have the second one, here we have third one, so this one will be the fourth one, and this one is fifth one. So the total number of intensity maxima detected by detector when the detector is moved from X to new position, that is 9.1 centimeters away from X, is 5. So total number of maxima is equal to 5. For question 5, it is given to us that a source of sound is moving in a circle and the radius of the circle is 2.4 meters. And source of sound is moving at a constant speed in a horizontal circle and the speed of source is given, that is 12 meters per second. And frequency of source is also given, means the frequency of sound produced by source is given, that is 950 hertz. So we can simply say this is Fs. In this case, F is equal to 950 hertz. And speed of sound in air is also given to us, and it is also given that observer is at rest. We need to calculate the minimum frequency, and in our answer we need to use three significant figures. First of all, let's try to understand when the frequency is minimum. Frequency is minimum when the source is directly moving away from listener. So here frequency will be minimum, and frequency heard by listener will be maximum when source is moving towards listener, directly towards listener. Directly is very important. When directly moving away, frequency will be minimum. When directly moving towards listener, frequency heard by listener will be maximum. Question is asking us to find the minimum frequency, so we need to simply use Doppler equation when the source is moving away and listener is at rest. So F minimum in this case will be equal to V over V plus Vs times frequency of source. Speed of sound is given to us, and this V is also speed of sound, and Vs is speed of source that is given, that is equal to 12 meters per second, and frequency of source is 950 hertz. We simply need to solve this one to find the minimum frequency observed by this listener. In this case, our answer is 917.6 hertz. But the question is asking us, we need to write our answer using three significant figures, means our answer must have three significant figures. So we can write down our answer 918 hertz. So this is our final answer, and it has three significant figures. For part B, question is asking us to calculate the shortest time interval between minimum and maximum frequency observed by listener. For this question, it is given to us that the source is moving in a circle and radius of circle is 2.4 meters. And the speed of source is also given, that was given in part A, and the speed of source is 12 meters per second, and the source is moving at a constant speed. Let's try to understand when the frequency is minimum. Frequency is minimum when the source is directly moving away from listener. So we can say frequency will be minimum at this point. And frequency will be maximum when the source is moving directly towards listener. You can also look at this diagram. When the source is moving away, in this case directly away, frequency will be minimum, and when the source is moving directly towards observer, means towards listener, frequency will be maximum. Now if we can find the shortest distance between these 2 points, then we can simply divide by velocity, means the speed of source, and we can find the shortest time interval. First of all, let's try to find out shortest distance, means the shortest distance between 2 points, and the shortest distance is equal to 2 pi r divided by 2, or simply we can say this is 3.142 multiplied by the radius. Radius is 2.4. We need to find shortest time, means the minimum time, that will be equal to minimum distance between 2 points, mean between this point and this point. So this is the minimum distance, and we need to divide by the speed of source. So if we solve this one, our final answer is 0.63 second.